Here is a very interesting problem. Q7, question 7. You are given a sequence 8, 14, 32, 86 and so on, and are told it is a geometric sequence with a constant term which has the form Tn equals to a r to the power of n minus 1 plus b. Describe how you could find the constant b. Well, think about it and then look into my solution. Okay. Now how do you do this? Now we are given this sequence 8, 14, 32, 84. First term is 8, second is 14, third is 32. If you see the formula Tn equals to a r to the power of n minus 1 plus b, you will notice that there are three variables a, n and b. So if there are three variables, you definitely need three equations, correct, to solve such a problem. So what we can do is we can write three equations using first three terms. We know T1 is 8, T2 is 14 and T3 is 32. And from there, these three equations will help us to solve the three variables, right? So let's do like that. So let's write down our three equations. So first equation where n is 1, right? So if n is 1, then we get 8, right? So we say 8 equals to, so 8 is for n equals to 1, correct? So T1 is 8. A r to the power of 1 minus 1, which is r to the power of 0, is 1. So it is just a, and then we get b here, right? So this is our first. Now the second one is when n is 2. So let's say n equals to 2. In that case, the term is 14. That 14 equals to a r to the power of 2 minus 1, that means r plus b, correct? Now if n is equals to 3, then we get 32 equals to 3. 3 minus 1 is 2, that means r square. So we get a r square plus b. You see, these are your geometric series with a constant b. That's what they meant. Now, using these equations, we need to find a, r and b, correct? In fact, they are asking for b, but you need to find all three of them. Now, how will you do it? Now, let us say this is equation number 1. Let's number these equations, okay? Let's say this is my equation number 1. This is, let me write 1, 2, and 3. Now, if I do 2 minus 1, so if I do 2 minus 1, that is equation 2 minus equation 1, then what should I get? So I'm doing 2 minus 1. So 14 minus 8, right? So what is 14 minus 8? 14 minus 8 is 6, right? So we get 6 equals to AR minus A, let me write AR minus A, and B minus B is 0. So we get this equation in terms of A. Do you see that? So from here we can get A in terms of R. So I can write this as, I can take A common, right? So I say 6 equals to A times R minus 1, correct? And that means that A is equals to 6 over R minus 1, correct? Let me write it here. A equals to 6 minus, so let me write this here. So A equals to 6 divided by R minus 1. R minus 1. So I'll make this equation 4. So I got term A in terms of R. Do you understand? Now, that is one part. Now, and I know B in terms of A, right? From equation 1, I know B in terms of A. So I can write B. So let me do it here first, and then I'll write what is B in terms of R, okay? So from equation 1, I know B is equal to 8 minus A. 8 minus A, correct? Now A is A times R minus 1. Oh, sorry, 6 over R minus 1. So we get 8 minus 6 over R minus 1. So that is the value of B. So let me write B here in terms of R, which is 8 minus 6 over R minus 1. And I'll write this as equation number 5. Correct. Now I know A and B in terms of R, correct? Now in the third equation, if I place A and B in terms of R, then I have equation only in R, correct? And then I can solve for R. Once I know R, I can find B and A. Does that sound good? Perfect. So we'll do like that. So we'll move on and say we use equation number 3 and plug in these values of A and B. So we will do, let me draw a line here so that it's like clear. Yes. So now we'll do equation number 3 and we say 32 equals to, instead of R, I'll write 6 over R minus 1. 6 over R minus 1, that is A, and then R square, correct? R square plus B. Now B is 8 minus 6 over R minus 1. Correct? So what we did is that we substituted 4 and 5 in equation 3 and got one equation in one variable R. Now it is easy for us to solve for R, right? So let's do it. We'll bring 8 this side. So we get 32 minus 8 is equals to, we are left with R squared divided by R squared times 6 divided by this and 6. So we can take 6 over R minus 1 common, right? And we are left with R squared here and minus 1 here, correct? Do you see that? Perfect. And what is 32 minus 8? 32 minus 8 is 24. So we get 24 equals to 6 over R minus 1 times R square minus 1 can be factored. And you can write this as R plus 1 times R minus 1. Correct? It is difference of squares, so it can be factored. And now I can cancel R minus 1. Do you get it? So if I do that, then I get the equation 24 equals to 6 times R plus 1. Correct? From here, I can solve for R. I'll divide 24 by 6 and then take away 1. Correct? So let me do this part here. And then I'll write down all the answers right there. So I'm taking from here, I'm going to divide 24 by 6. So let me write it here. 24 divided by 6 equals to R plus 1. Correct? 24 divided by 6 is 4. 4 minus 1 equals to R, or 3 is the value of R. So we got R as 3. Describe how you could find the constant B. Now R is given to us 3. We can plug this 3 here and find B. Okay, so let's find A also. So A equals to 6 over 3 minus 1. So it is 6 over 2, which is 3. And B is equal to, we can write B as 8 minus A, right? We'll use this, 8 minus A, right? So 8 minus A, which is 3, right? 8 minus 3, which is 5. So A is 3 for us and B is 5, correct? You can check the equation, whether it works or not. So the first term will be 3 plus 5. Do you see that? Let me write that term as here 8 as 3 plus 5, right? Then the next term will be R is what for us? 3. So 3 times 3 is 9. So you get 9 plus 5. Do you see that? Now 3 times 9 is 27. So you get 27 plus 5. And so on. Do you see that? So that is how we get our series and we get the values for our A and B. Okay, I hope you enjoyed the process of solving this equation. It was kind of complicated but interesting. Thank you.